All right, so let's talk about the modulation transfer function. So in your exam, if you were asked what is the MTF, what is its range, and how do you obtain it? Or for example, you may just see this graph. So we see the modulation transfer ratio times the spatial frequency here, and then we have an MTF curve. So MTF characterizes the performance of an imaging system and it measures spatial resolution. It is a property of the imaging system. Now, how well the spatial resolution of an object is reproduced by the system itself. So, important to know, it is a property of the imaging system as a whole. So, it's not saying how well necessarily resolution is or things like that, but how well the spatial resolution is reproduced by the system. So it's not going to make the resolution better, or it could technically make it worse, but it's more about how it can reproduce. So now the range kind of from here is nice, depending on what you, if they give you a graph, but you can see the modulator transfer function MTF can go from 0 to 1. So now what do these mean though? So if we have the MTF, let's consider this, say it is less than 1. That means there is, I'm just going to put SR for spatial resolution. Some spatial resolution is lost. Now a MTF of 0.1 means that is unresolvable. So essentially, you can't see anything. It's unresolvable, horrible resolution. Now, there is no good or bad, mind you. Also, 1 means that it is absolutely perfect. So there is a perfect reproduction of the spatial resolution of whatever you are looking at. It doesn't mean the spatial resolution is perfect, but that the reproduction of it is perfect. So as I was saying, there is no good or bad. All you care about is the baseline. So an imaging system can degrade due to failure of components or old age. And what you care about is what the imaging system started at, and over time, is it getting worse? So ideally, you don't want a really steep curve. So say I get my imaging system, let's just say right here. I get, it could be anything, say our CT, that's perfectly fine. We get our CT, cone beam CT on the LINAC, whatever it is. Say we have this, and that is our baseline value. If you're seeing something like this, a really steep curve, that's bad. It means you're losing that spatial frequency very quickly. Whereas if it's something much more gradual like this, and then dives down, that's much better. So how do you obtain it? So you can use the CAT fan. There is a QC3 phantom. Mobius has a phantom. Standard Imaging has a phantom. Essentially, it is the Fourier of a line spread function. So a sharper line spread function means less spreading and a slower drop off in MTF, which is good. So that, don't go too much into the weeds, because clinically what we need to know is that there is a phantom, you can scan it, and then there are different softwares that does this Fourier of the line spread functions and can tell you what the MTF is. It's important that we run this test, we graph it, and we know how our baselines are doing and overall how our imaging systems are. So don't go too far into the weeds with MTF, but it is important to know. It's something we need to check as medical physicists. If you have any further questions, please comment below. Although I'm not going to lie, a diagnostic physicist may be able to answer your questions a little better, but I will do the absolute best I can. Best of luck studying, and we'll see you in the next one.